Hello, my name is Husam Samkari, and my co-author is Professor Brian Johnson from the University of Idaho. We would like to thank the IEEE PES General Meeting Committee for accepting our paper. I am pleased to present our paper titled Impact of Distributed Inverter-Based Resources on Incremental Quantities-Based Protection. Our paper characterizes the response of incremental-based protection to inverter-based resources, or IBR supplied fault current. The incremental quantities, also known as superimposed quantities, is fault-generated instantaneous components of voltages and currents that are largely dependent on the electric network parameters. The impact of IBRs are demonstrated in a modified IEEE 34 bus distribution system using an electromagnetic transient program. And what motivated us to conduct this research is the increasing interest in using incremental-based protection. And the reason of that is the fast tripping advantage, where few researchers focus on evaluating the impact of IBRs on the incremental quantities. Here is one example from the simulation results showing the impact of IBR compared to other resources such as wind turbines and synchronous generator. In the case of IBR supplying the fault and the incremental quantities and power quantities signals are not reliable, as well as the replica current and power. However, we can see that the incremental voltage quantities are not impacted. The main reason for this behavior is that the IBR control acted fast to regulate the current. On the other hand, the incremental quantity signals are more reliable when the wind turbine type 1 and the synchronous generator are the main sources of fault current. More specifically, the replica current and power are reliable because a replica impedance filter removes the decaying DC offset. We conducted several cases and scenarios to verify this issue. For example, we have cases with a non-zero fault resistance and different fault types, such as three-phase, double line to ground, and line-to-line faults. Also, we changed the IBR controller mode from a fixed to active power reference to volt-var mode, which allows the IBR to vary reactive power in order to regulate the voltage at the point of interconnect. But the same issue of not indicating the correct fault direction is observed. Based on our study cases and the simulation results, we concluded that the IBR negatively impact the current and power incremental as well as replica quantities, and that is because of the IBR fast control response. As a result, the incremental quantities-based directional element might fail to detect the correct fault direction. And also we noticed that the voltage quantity signals are reliable, which can be used only to detect the presence of faults, but cannot identify the direction of faults without a reliable current signals. Further research is required to improve the incremental-based protection or the incremental quantities-based directional element when IBRs are the main source of fault current. Thank you for your attention.